All right, day 168, making circuits today. This is really fun stuff. So, still working towards this goal. How do we build a motor out of magnets, wire, and a battery? In order to understand how to do this, you need to understand how charge flows, and that's what happens in a circuit. In a circuit, charge flows. We call it current. So, we're going to look at resistance and Ohm's law, explain why a switch has to be closed in order for current to flow, describe how electrons flow in a circuit, that's the charge, and create a successful simple circuit. Those are your goals. For the warm up, do it. Okay, if something's conductive, what can it do? Well, it can allow charge to flow, right? It can allow current. Materials that are conductive. Copper is a great one. Most metals. The water is actually not all that conductive, but the minerals that are in water, right? You know, water's not just water. There's other stuff in there. And those things are really conductive. And yeah, that's most of the stuff right there. Okay, so we talk about rulers measuring things in centimeters and millimeters, and ammeter measures amps. All right, it's the first couple letters there. Amp is AMP, and that's the unit of current. And Ohm's law, well, Ohm's law says, I think it's here. Doopity-doo. Doopity-doo. All right, so we got the Ohm's law is a pretty simple equation, but the greater the voltage, all right, voltage is pressure, the greater the current, and the greater the resistance, and think of resistance as friction, right? Resistance to things moving, the lesser the current. So basically, that's what Ohm's law says. You've got two things affecting the current. One is voltage or pressure or push or force, and the other one is resistance or friction or a reductive force, right? So you got these forces on both sides. Okay. So a little review, what causes things to move? Pressure, that's called voltage. We've got lots of different things that we think of with little batteries. A little AA or AAA battery has 1.5 volts. You can see it on the side of the battery. And that's enough to move things like little toys, but bigger toys require a bigger push. And so usually they need a bigger, not necessarily a larger, but just a higher voltage battery. You can also have a larger battery, which is able to sustain the voltage, like a car battery. It's only 12 volts, but it's very big. Resistance is what resists movement. Little thin wires usually have lots of resistance. And if you think of a big extension cord, especially one that somebody might use for powering a energy-hungry device, they're really thick. Not this thick, but they're really thick like this. Right? They're really, really big and beefy. Have a small one right here. Right? This is bigger than your normal cord. And so the result of all that stuff, again, is current. Okay, we've got a lab today. The instructions are here. Not like some tangerine juice. And so you'll notice at the beginning of this is what we did in the warm-up. So you can just put your answers right there. And some instructions for how to do things in the lab are here. And you're going to start off with making a basic circuit. So let's just do that real quick. And then the rest is pretty common sense. So here's the link. Let's hit play. Okay, let's see. Which one are we supposed to go to? Intro or lab? Pretty sure it's lab. So let's go there. Okay, so we need to make something with a light bulb, a switch, and a battery. And they all have to be connected. So basically, you're just going to follow that. So need some wire. Just grab it, drag it out. I'm going to grab out a few pieces of wire. And we'll throw a battery down here. Notice if you get the... See, if you connect these circles here, and then these ones, you can get them to attach. So I'll put the light bulb up here and the switch. There we go. See, only one side connected. Now it turns black when it gets connected. I need one more wire. So I'll put one in there. As long as everything is black, that means they're all connected. Now, obviously, the light's not on because the switch is open. Now the switch is closed, and you can see the electrons are flowing, the charge is flowing, and the light is shining. And it says down here, the switch is closed. You've got some tools over here that you can use. You can use the voltmeter to see the voltage at different sides. This is a 9-volt battery that we're using right now. So, lots of fun stuff you can do. You can also change things to make this look like a circuit diagram. You can make the current go away, so you can just see the diagram. You can leave it. You can change the resistance of the wire. You see that lowers the pressure, slows things down. And there are lots of other things that you can put in, and we will mess around with all of these. So there you go. Pretty straightforward. If you have any questions, let me know. But this is a pretty cool activity. For when you're done with that, first flipping physics video ever about current. It's great. Kind of cool to see how far he's come since then. So the link's there and the questions are right here.